All right, so today we're just doing a midterm review, and the form that will take is I've got the midterm as well as the main question bank if we need to do more. But I've got the midterm from last year. Uh, let's discuss a little bit about the format so that you understand that. Of course, it's this Thursday, March 5th, regular time, 11 to 12:15 for this course. We're right here in Avery 115, again, the normal room. And the format is about 25 multiple choice questions. That's what the format was last year, and so I'll just use it again. They are randomly selected from a pool of about 200, 300 questions. It is Scantron, so physical Scantron sheets. Oh, right, here we go. You know, these old traditional bubble sheets, right? Where you're going to fill in the bubbles. You'll fill in your name and your NUID. Actually, your name is all we need. Your last name first, of course, please. And we'll scan them, hopefully get them back by the end of the week, Friday. But the reason it's Scantron, old school Scantron, is because if we do it in the testing center, I can't let it be open book, open note, open computer. Which is exactly what I'm going to be doing. This is an open book, open note test. You can use whatever you want. In fact, it's a little bit of a required computer. So if you've got a computer, bring it with you, because what I will do is I will do exactly what I'm going to do here. I'm going to make it available electronically. So you can download it from a URL, the actual handout here with the questions. The only physical thing that you should have is your number 2 pencil and the Scantron sheet, which I will provide. But if you do not have a computer the day of, then we will have a limited number, maybe like 10 or 15 actual physical copies of it that I'll print out. I just don't want to print out 150 copies. So keep that in mind. Make sure that you bring a computer if you've got it. The topics, of course, are going to be everything up to the midterm, up to what we did last week. Basic Java, object-oriented programming, and object-oriented programming in the context of Java, SQL, and database design. So you might be given, in fact, we'll see it here in a second, you might be given a toy database and then asked, how do you formulate a query to do this, which one of these queries does that, etc. So any questions in the format? Yeah. Are we allowed to use IDE? Sure. Yeah. Oh, I mean, if you bring your computer, of course. Of course, no communication. Don't use your computer or your phone or whatever to communicate with anybody inside the class or outside the class. Okay. All right. Well, here is the exam from spring 2019. Right? And we start out with basic Java here. Consider the following piece of Java code. Oh, by the way, I guess maybe a little bit more on the format. It's 25 multiple choice questions. It's worth 75 points, which is roughly about 5% of your final grade. Right? You'll notice that the final also is worth about 5% of your final grade. The vast majority of the points in this course are going to be from your homework. Your homework is the project-based homework is 75% of your grade, 75% of your grade. That's where you should be focusing most of your efforts, and I'm trying to impart on you the importance of starting those early. For example, you should try to get a draft of your database design done by Thursday so that you can hand in an ER diagram along with your third draft copy of your design document. You don't have to have all of the test data in your database. You don't have to even have it in a final state. But you certainly should have a draft of it done by Thursday so that you can take it to an LA. This is what I've been suggesting to everybody. Take it to an LA and let them critique it. Like say, okay, well that part looks good. That part could be improved, right? It's like having a live grader in addition to the web grader where you're submitting stuff and running it over and over again. You can ask LEAs about design, right? And they will give you some feedback. You can come to my office hours. Some people have already done that and asked about design, right? Sometimes it's been after the fact, but if you come before, certainly we'll give you some tips, right? So keep that in mind, that the vast majority of your points for this course are based on the homework. So this exam is nothing to fret over. If you want to worry about something, worry about your design and tell yourself, I've got 2 weeks that I can do this in. Let's go ahead and get it done a week ahead of time so I can take it into an LA, or a draft of it a week ahead of time so I can take it into an LA and get some feedback on that design. All right. Back to the exam. Consider the following piece of Java code. So this is basically an integer array. This is old school integer array of size 10. Once we are done using ARR, to free up memory, we would A, Java automatically handles its own memory management. B, call the free method, system.freeArray. Use the old keyword. Array is equal to old int, right? Just the antonym of new. Set the array equal to 0. So which one of those is the most correct? A, right? Java automatically handles that stuff for you. You don't need to worry about garbage collection. You don't need to worry about memory management like you do in C. It takes care of that stuff for you. Now, that's not to say that you can't have memory leaks in Java. You can. It's just that they take a different form, right? Holding on to references to stuff that you no longer need. In Java, you can use interfaces and abstract classes. What's the difference between the two? You can create instances of an interface, but not abstract classes. You can create instances of an abstract class, but not interfaces. An abstract class must implement an interface. Or D, you can implement it in multiple interfaces, but you can only extend at most one abstract class. So which one of those is true? D. You cannot create instances of either. An interface is a pure abstract class. And you can't create instances of an abstract class, as many of you have designed your asset classes. You design the asset class to be abstract so that nobody could create just this generic asset that have no way of computing the actual value of that asset. But of course, you can implement multiple interfaces. But Java is a singly rooted inheritance hierarchy, so you can only extend from at most one class. Right? The method in a subclass can be overridden. Many of you have been using that @ override, or have allowed Eclipse to generate that @ override annotation, right? To change how a subclass behaves. Which method is invoked is determined by what mechanism. So it's an intermediate join table. Does that sound right? Join tables are database related, right? Not object-oriented programming related. It's determined by the compiler using static dispatch, maybe. At runtime using dynamic dispatch using a virtual table, or by overloading the Java virtual machine itself. Probably not D, that's just nonsense. But what about B or C? Which one is it? So is it done at compiler time? If you've got bird B is equal to something, right? Do you know exactly what kind of bird that is at compile time? Not necessarily. Right? So how does it determine that let's see, birds, what was it? The fly method is called, or the walk method is called if it's an ostrich? How's that done again? Remember that diagram? That when you create it, there is a reference to the actual method that it invokes, and then there's another reference, like the arrow over to another. Right? What was that table called? Called a virtual table. Right? It's a virtual table that keeps track of all of the methods in a class. Okay. And so it's done at runtime by dynamic dispatch. It's done automatically through signal sending or signal message handling. Right? You send a message to the object to invoke your move method, whatever that might be, and then it's the object's responsibility to dispatch that dynamically at runtime to whatever method it was pointing at instantiation. Right? So virtual table. Let A be a subclass of B. So B, and then A is a subclass down here. Which of B's variables does A have access to? So variables up here in the superclass, variables down here in the superclass, down here in the subclass, excuse me. What variables can we see from above? Private variables, public variables, protected variables, all the above, or public and private, or protected, excuse me. So which ones? Which? E, right? I was hearing E's and D's. They sound very similar, sorry. All of the above, no, we cannot see private variables. Right? You can only see public and protected variables in a subclass. Anybody can see public variables. All right, protected variables can be seen by subclasses. Private variables can only be seen by instances of the class itself. So if you create a private variable in an asset class, nobody else can see it except the asset class. That's why we have getters and setters down in defined up here, and then you can control access to the outside world of those, with those. Assume you have a class named checkInventory with an abstract method repeat error, or report error. We have an inventory system, and we may need to report an error with the inventory that we're out of valve indexes to be sold, right? Likewise, assume that you have two classes, search inventory and count inventory, both of which are derived from check inventory. So check inventory, and then we've got two subclasses, similar to bird, ostrich, robin here. Search inventory and count inventory are the subclasses. The method report error in search inventory sends an error message to the manager, right? While the report error method in the check inventory writes an error message to a text file. So we've got specialized behavior down here in the subclasses. All right. Suppose inspect is a variable instantiated with this line of code. So we've got inspect. It's being treated as its superclass check inventory, but it is an instance of search inventory. And remember that search inventory, what did it do? It sends an error message to the manager. So invoking inspect.report error, what does it do? It sends an error message to the manager. So which one of these is correct? Which one of them is false? So it sends an error message to the manager. That one's correct. It is valid Java code, yes. Writes a message to the text file. That's the one that's wrong. What's right about D? The above is an example of polymorphism. There we go. Right. There we go. So yeah. The answer here would be C, the thing that it does not do. The sibling of that class does that. Say that you have the following line of Java code. List of strings, product descriptions equals new array list of strings. This is the old school way of doing it. Of course, you can elide that by using the diamond operator instead, and leaving off the string right here. Which of the following is true? Adding a non-string type to the product descriptions will result in a runtime exception. Okay. The upcasting, here that we're treating an array list like a list, right? And unfortunately I'm not going to be able to highlight this, but an array list is being treated as a list. The upcasting indicates that product descriptions is a list now and not an array list. Is that true? No, it's still an array list, but it's being referred to as its list. It's both, right? Because inheritance follows that is a relationship. A subclass is a type of its superclass. Adding a non-string type to product descriptions will result in a compile time error. Right? So same question here, or same answer here on A and C, but is it a runtime exception, or when it's actually running, or is it a compile time error? And then finally D. The code is invalid. A list can't contain string types. That's just nonsense. You know that, of course, they can contain strings. They can contain anything that you want because you are parameterizing it. So now, if I tried to add, say, an integer to this list of strings, what's going to catch that error? Is it the compiler, or is it going to be the at runtime? It's going to throw some sort of an exception. The compiler is going to catch that, right? That's the whole point of having parameterized polymorphism, that a lot of stuff becomes compiler errors, and so the compiler is able to check, this is a list for strings. You're adding something that's not a string. Therefore, compiler error, you can't do this. Right? A class constructor method is used to initialize an object at the time of its creation. Right? So constructors. Suppose that the only constructor explicitly defined in a class is a non-default constructor. That is a constructor that takes parameters. Which of the following is true? The default constructor provided by the compiler can still be used. Any instances created from the class will be initialized with appropriate parameters. A class can have only one constructor, either defined by the programmer or the default, but only one. Right? And D, the class will never need its own constructor, since it can always call its superclass's constructor. So, which of the following is true? B. Is the default constructor provided? No, remember, by default it's provided, but the second that you define your own constructor, the default constructor goes away, lab 4. What about C? A class can only have one constructor. Is that true? No, you can have as many constructors as you want. Copy constructors. Some constructor that only takes a subset of the values for that object, right? You get the default constructor with no arguments. A class will never need its own constructor since it can always call it super constructor. Well, sometimes you need your own constructor. So the correct answer here is B. Any instances created from the class must be initialized with the appropriate parameters, right? If you have a constructor that takes 3 parameters, you cannot invoke new and provide it 4 parameters or 2 parameters or something like that. And the parameters have to match. If it takes 3 strings, you can't give it 3 integers. That'll be a compiler error. When a value of static method is used from the string class, of which there are many versions, how is it determined which method should actually be executed? So the string class has 3, maybe 4 value of methods. This is similar to the math library. Math library has 3 or 4 absolute value methods, right? But they have all the same name, but they just take different types. What is that called? An explicit flag must be passed by the programmer to indicate which method should be called. So do you have to say, I mean for you to call me that method over there, and there's some special flag variable that you set. The compiler is able to deduce at compile time which method to call based on that argument list. That sounds a little bit better. The first method found satisfying the method is the one that's called. So it just starts searching, no, that one's good enough, I'll take it. No. This can only be determined at runtime and may cause runtime errors. B, right? What is that called again? So it's not, if something happens at compile time, it's generally referred to as static. If something happens at runtime, it's generally referred to as dynamic. We've already had a question here up above about dynamic dispatch, where at runtime it sends a signal to the class and the class determines I need to call that fly method over there, or I need to call that walk method over there. Right? That's dynamic dispatch. What would this be called then if it's a compiler is responsible for it? Static dispatch. Right? And the word static dispatch didn't appear in this question, but that's what it is. Assume you have a base class called book. Furthermore, assume that you have 2 subclasses called mystery and fiction. Which of the following is true? Casting an instance of mystery as an instance of fiction is safe. Is that true? No. What kind of casting an ostrich as a robin or a robin as an ostrich? What is that called? Say what? Not contra. Hold that thought though. Invariant, right? It's an invariant coercion. You cannot make a mystery novel become a fiction novel, just like you can't make an ostrich become a robin. Casting an instance of fiction, so the subclass, as an instance of book is safe. Yeah, that's safe because a book or a fiction is a book. Right? Now that's called what? Not contravariance, but the other one is covariance, right? Casting an instance of book as an instance of mystery, so taking a superclass and forcing it to become a subclass, is safe always? No, sometimes it's not safe, and that's contravariance. Right? Casting between any combination will fail. No, of course you can cast some of those combinations. So which one of the following is true? What was it, B? Fiction as an instance of book is safe. Right? That's the covariance, covariant coercion. Suppose you are required to upgrade the software system for an accounting firm. Currently, they have classes corporate customer and accounts payable. Further, suppose that corporate customer owns a collection of asset instances. That sounds familiar, right? If accounts payable has a method, a public method, public double, that should be highlighted there, public double get total assets, which computes the total asset value of the corporate customer. Does this indicate a faulty design? That one's terribly worded, so let's go ahead and parse this out. It doesn't say that there are 2 Maybe the accounts payable has a method called get total assets, which computes the total asset value of a corporate customer. Ugh. Okay, so let's read the answers here. That's kind of poorly worded. I would definitely reword that or cut that question. But no object-oriented principles are no, comma. Object-oriented principles are not violated by this design. Okay. No, corporate customers should own assets regardless of how the total is computed. Yes, it ignores composition between a corporate customer and its assets. Yes, it breaks encapsulation. I think that the intended answer there is yes, it breaks encapsulation. If a corporate customer owns a bunch of assets, why is another class called accounts payable computing anything about its assets? Right? That behavior belongs in the class in which where the data is located that it operates on. For example, now forget about this example here. Let's make it more relatable to what you've been doing in your project. If you want to compute the total of all assets, that you want to sum them all up, where does that behavior belong? In the portfolio class, right? Why? Because portfolio owns, through composition, a list or set or collection of assets. Right? Now, if you wanted to compute the value of an asset, one asset, where does that behavior belong? In the asset class. If you want to compute the value of a stock asset, right, the number of shares times the share price, that belongs in the stock class. Right? If you want to compute the value of a deposit account, which is the balance, that belongs in the deposit class. Right? So don't break encapsulation by locating behavior outside that class. Right? Suppose we design a student class that owned an array of instances of exam class. This design is best characterized by what? So the keyword here is owns, and owns is that inheritance, composition, abstraction, or polymorphism? Composition. It's composed of other things. So we have a student that owns an exam class. We could say what? Oh no, okay. That owns a midterm exam or something, right? And then the exam holds the scores or holds the questions or something like that. It's not inheritance because is a student an exam? No. Is an exam a student? No. It's not abstraction because abstraction deals with how something is represented. So like a student has a first name, last name, or whatever, right? Or an exam has a list of questions. Right? Which of the following is true about the keyword final in Java? When used with a method, subclasses cannot override the method. The final keyword can only be used with variables. When used with a class, that class cannot be instantiated. When used at the end of a block of code, that code is executed regardless of any thrown exceptions. Let's start at the top here. When used with a method, subclasses cannot override that method. That sounds reasonable, right? Remember what we call those? So a virtual table has what's called, maybe I didn't cover it directly, but a virtual table has virtual functions, right? We call them methods in Java, virtual methods. And by default, everything is a virtual method. If you want to make something non-virtual and not allow a subclass to override it, you make it final. You can make the method final. Just like you can make, we did cover, however, making a class final. For example, integer. The integer class has a well-defined behavior, and everybody has expectations of what an integer is. That an integer plus an integer is an integer. You can multiply two integers together and get an integer, right? That integer divided by an integer would result in an integer with truncation, et cetera, right? That class has been made final so that you can't subclass it and create my integer that suddenly has different behavior. Like, well, an integer multiplied by an integer is now a random number, right? No, we're not going to allow that, so we make it final. You can apply that to an actual method, in which case the method becomes final, and you can't override it. What about B? Or A is the correct answer. What about B? The final keyword can only be used with variables. Is that true? Nope. You can use it with variables to make them constants. You can use it with methods to make them non-virtual and you can't override them. You can use it with classes to ensure that you can't subclass that class. When used with a class, the class cannot be instantiated. No, it just means that it can't be subclass. You can't extend that class. When used at the end of a block of code, the code is executed regardless of any thrown exceptions. Does anybody know what that's referring to? Similar to finally, right? So you can have a try, catch, and then finally will take care of any closing of resources and stuff like that. We'll cover that when we get to covering JDBC next week, right? Java Database Connectivity API. Which of the following best describes object-oriented concept of polymorphism? Hiding specific implementation details from the client, a client code, declaring a class that owns another class as a member, treating instances as different types at different points in the program, or casting a subclass to references of its superclass. So that has nothing to do with this code down here. That's the next question. So what is polymorphism? Which one of those things is polymorphism? C, treating instances as different types in different parts of the program. What is A? Hiding specific implementation details from the client. From the client code, right? Hiding the details. So you don't have to worry about how is time represented? How is a date time represented? How is this list represented? Well, there's an array underneath the hood, right? Or how does this square root method work? Right? Again, the answer is who cares? Why? Because you don't care about the details. It's abstracted away. So A is referring to abstraction. Declaring a class that owns another instance of a class. What is that? Owns. Keyword here should be you should always be thinking about composition. Casting a subclass as references to its superclass. That's a covariance, right? So that's kind of a more inheritance. Right? Refer to the code snippet in Figure 1. So we've got an abstract animal class that speaks. We've got a subclass here, non-abstract, so you can actually create a dog that barks, and a cat that says meow. Right? Which of the following is, so I've got an animal A, which is a dog, and then animal B equals new animal. Right? So animal A is going to be a dog. Does this look suspect already? What's wrong with this? Animal is abstract. Can you create instances of abstract classes? Nope. So the first declaration is invalid. A dog cannot be treated like an animal. No, a dog is an animal. The second declaration is invalid since you cannot instantiate an abstract class. That's the correct answer right there. The second declaration is valid since the types match. Right? That doesn't matter. The first declaration is valid but unsafe as it represents an invariant relationship. Is it? No. What would represent an invariant relationship with these classes right here? Trying to treat a dog as a cat or a cat as a dog. Okay. Hey, that looks familiar. Slightly different though. It's using old school underscore casing here. We've got video games, publishers. Publisher to video game is a one-to-many relationship. One game has one publisher, but a publisher can publish many games. They're available on platforms with a many-to-many relationship between them. The video game database consists of 4 tables. Assume that all fields of each key table were included when it was created. Which of the following is most likely describes the order in which the tables were created? So we've got a dependency here. Can a game exist without a publisher? Nope. So can a publisher exist without a game? Yeah. Can a platform exist without a game? Yeah. Can a game exist without a platform? Yeah. But can an availability record here exist without a game? Nope. Can it exist without a platform? No, it needs both of those things as foreign keys right here. So what order would you have created these tables in order for this to be valid? What's the last thing that you would have to create? Availability. Then you can create game, platform in any order. But before that, what do you have to create? Before game, what would you have to create? Publisher. So what's the answer? Availability table was created first. Definitely not. The publisher table was created first, then platform, then game, then availability. That seems likely. The game table was created first. No, you can't do that without the publisher. The question is moot. The order of tables were created doesn't matter. Is that true? Not at all. Order matters. Which of the following statements about basic database functionality is false? SQL provides functionality to retrieve records using the select statement. Yeah, that's true. SQL provides functionality to add new records with the update statement. That doesn't sound right. Update is for updating currently existing records. SQL provides functionality to delete records with the delete statement. That sounds true. None of the above are false. That is false. So B and D technically, but that's only because of self-reference, right? And that's kind of like the sentence that says this sentence is a lie, right? Well, if it's a lie, then it's telling the truth that it's a lie, and so it's not a lie, right? And if it's true, then it's telling a lie, so it can't be true, so it's false, right? So take out that D right there, right? What is the difference between join and a left join in SQL? What is the difference? A left join preserves records, right, from the left. A join creates new records. That's nonsense. A join preserves records that are in one table but not the other. A left join preserves records that are in one table but not the other, or they are the same. So which one is it that preserves records? C, left join. Min, max, and average are examples of SQL queries that return a result set. Yeah, technically there's a result set of 1. The actual number, the max, min, whatever. But they're aggregate functions, right? They aggregate a bunch of data together. They aggregate. Do they require a group by clause? No. What does a group by clause do? It projects the data down and gets rid of one dimension so that you can find the total number of all books copies by author. That was the example we did. I forget what the example was with the albums database last week, though. SQL aggregate functions that require a join clause? No, you can use them independently. There's another database. There's a person table and an employee table. Say that we wanted to insert a new employee into the database in figure 3, this figure right here. We would need to insert a record into the employee table first, and then into the person table. Insert a record into the person table first, then into the employee table. Formulate a compound insert query to insert both tables simultaneously. As defined, this operation is not possible. So C and D are clearly nonsense. Which order do you have to go in here? B, that a person record has to exist before an employee record can exist because it needs a person ID. Okay. Yeah. Not the casing that I would have used, but at least it's consistent, and that's the important thing. Naming consistency is the most important thing. It doesn't matter what you actually do. Consider the database again in figure 2. Oh, no, that's all the way up there. We can click on that. That's another nice thing with the handout that you'll have. It's PDF, so you can actually click on it and take and go back and forth here, depending on your PDF reader. What were we on? Darn it. There we go. 20. Consider the database, again, the video game database. Say that you would like to know how many platforms each game has been released on. Right? So I want to know how many different platforms has Animal Crossing. There we go. Animal Crossing's been released on. That releases March 20th for those interested. I'm getting it for my kids. That's why. And Doom Eternal. What? And Doom Eternal. And what's Doom Eternal? It's a what? Oh, okay. I'm not getting that for my kids. No. I mean. Isabel's a big fan of Doom. No, I never got into those games because first-person shooters like that just give me a headache after like 20 minutes. So I cannot play those games, especially the old ones where it was like kind of static. Right? The old Doom, that is. All right, so consider we want to know how many platforms Doom was released on. All right, which one of these things would do that for us? So let's start down here. Count star from platforms. What does that do? That counts the number of platforms in your database, not the number of platforms that Doom has been released on, or that each game has been released on. So that immediately eliminates D right there. What's the difference here? The select statement in all of these is the same, Select g.name, count star from game G. Left join availability on blah, blah, blah. Left join availability A on group by, or join availability A and group by. So let's go ahead, and two of these have left join. One of them has just a join. What are we leaving out if we just use a regular old join here? Games that are available on no platforms. And I want to preserve that. So that brings it down to A and B. What's the difference here? One of them uses a group by clause and the other doesn't. If you want to project it down and count up the number of platforms that it's available, that Doom, and then the number of platforms that it's available on, and collapse that down, what do you need to do? You need to group by the game ID. Right? So B is the most correct answer here. Which of the following is most true of the following query? Delete last name from person. Right? Now this is referring to the employee database. That's not valid SQL. The query deletes the last name column from the person table. I mean, that's what it looks like it does, but do you think you can do it that way? No. What does delete do? Delete deletes records, not columns. Right? The query deletes all records in the person table. You could do delete from person, right? Or delete, from person, but without a where clause, then you get into whether or not it's in safe mode or not, and that's very dangerous anyway. The query is valid SQL, but has no effect. Right? It's not valid SQL. You can't delete a column. You can change a pre-existing table. You'd have to use like an alter table add column, or alter table delete column, I think it is, or maybe it's drop column. That we don't get into that. That's if you want to get into that kind of level of database stuff, then that's beyond the scope of this course. Right? It is not valid SQL. If you're running your IDE like you asked, can we do that? Yeah, sure. Go ahead and try it and see what happens. Right? Which of the following statements about tables in Figure 3? Again, that's going to be the employee database right there. And what number were we on? 22. Which of the following statements about Table 3 is most accurate? There's a one-to-many relationship from the person table to the employee table. There's a one-to-many relationship from the employee table to the person table. There's a many-to-many relationship between the two tables, or there's no relationship between the two tables. So which is it? There's a one-to-many relationship from the person table to the employee table. If you reverse that perspective, there is a many-to-one relationship from the employee table to the person table. Right? So which was what was the answer? A. Person table to the employee table, there's a one-to-many relation. Good. Which of the following statements about primary keys is false? The primary key is a unique identifier for each record in a table. That sounds good. Okay. Primary keys are in separate tables cannot have the same value. That sounds odd. Why would a primary key in the employee table have anything to do with a primary key in the employee table, for example? A primary key can consist of no more than one column. It can consist of more than one column. Yeah, you can do that, but I would not recommend it. A primary key can either be auto-generated by the database or defined by the designer. Yeah, you can leave off that auto-generate, and then you're doing your own key management if you really want to. Again, not something I would recommend. So primary keys in separate tables cannot have the same value. That is absolutely false. You can have a game with ID 1, and you can have a platform with ID, primary key ID 1. Right? That's perfectly fine. Last two questions. Which of the following would not be considered a best practice when dealing with SQL and database connectivity? Don't worry about that. We didn't cover JDBC. Cut that. If you want to know the answer, though. Resources, that is result sets, prepared statements, connections, should be released as soon as they are done processing. That is true. Prepared statements should always be used to ensure safe SQL queries. That is true. It protects you against something called an SQL injection attack. This is all something that we'll cover next week. Defining foreign keys should be avoided so that the types of queries won't be restricted. That is absolutely false. Right? That is a terrible practice. Not defining foreign keys is terrible. Use of the star operator should be limited to protect code against changes in the underlying data model. that is also best practice. Don't use the star operator in your actual JDBC code. Right? We'll cover all that next week if you're interested. But if you want to know the answer, the answer was, what was it? Not be considered best practice would be C. Consider the database, again, the employee database here. Suppose that the database is populated with various employees, each with respective positions and salaries. Furthermore, suppose that you need to generate a report that lists each employee name with their salaries. Which query would accomplish that? So I want an employee with their name and their salaries. Select the first name, comma, last name, comma, salary from person. Join employee on person ID. Okay, that sounds kind of, there is something called a natural join, and I think that that's what this is doing, but that doesn't sound right to me. Select P dot first name, P dot last name, salary from person P, join employee E on, and then the person IDs have to match. That sounds a little bit better. What's the difference? E dot salary versus no E dot salary from person P, join employee, blah, 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 same stuff. Which one is more right between these two? C, because you're actually aliasing it as E. You aliased it down here. It might still work on B, but I'm not sure. Select P dot first name, P dot last name, sum of all salaries from person P, and then join. That doesn't sound right. If you want the first, like Joe Smith's first name, last name, salary, you don't want to sum up every salary in the entire company and then say that Joe Smith is earning the entire salary of the entire company, right? So what's the answer? It looks like C to me. Okay. So let's take a look at that more closely. Let me ask you some follow-up questions here. If I did a join query from the employee table to the person table, would I have to do a left join to preserve records? No, because an employee, can they exist without a person? Nope. So if you're going from the employee table over to the person table, left join and right join, or left join and regular old join would be the same thing, because you have a guarantee that a person, that employee cannot exist without a person ID. Going the other way though, if you want all people joined with all the employee records here, where say Joe Smith can have both the CEO job and the janitor job, right? He's got multiple jobs over here. But then you also have John Smith down here. Maybe he's not yet been hired, but we have that, that employee record. What kind of a join would you need to do to preserve those records? A left join. Right? Now, if you reverse those and you did a right join, then that would preserve those records as well. Right? Okay. What else? Say that I inserted an employee and they had a really long job title. So CEO, CFO, I just saw one just this morning, Chief Learning Officer, CLO, right? We just have to keep creating more C's in order to create more jobs, right? more like corporate jobs, right? But then this person is the vice president in charge of blah, 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 and say that it took 1,000 characters to describe their job title. Would that work with this database? No. What's the maximum number of characters that the title can have? 255. It'll end up truncating it and only taking the first 255 in whatever string you give it. Right? We've got enough time here. How would this database have been created? That's the ER diagram, right? So if you go up in MySQL Workbench, you go up and you hit generate ER diagram from model, reverse engineer this. This is what it'll spit out. How might we have created that in the first place, though? Move down here. Let's write some SQL code to do this. So you already answered the question of which one would need to be created first. Person table. All right. How do I create tables? Create table. If not exists, if you want to put that in there, I'll just go ahead and do it short and sweet here. Create table, person. Is it curly brackets? No, it's what? Parentheses. Semicolon or not? Yes. Right. Person ID, comma, or comma, good. First name, comma, last name, comma. Nope, not on the last one. Person ID. That's not my primary key, so how would I write that? Int, good, it's an integer. Right? You know that from up here, int. Primary key. Is it allowed to be null? Probably not, hopefully. Not null. Auto increment. You're not going to be able to glean that from just the ER diagram here, but of course that's standard practice here, or that I've shown you at least. First name is going to be a varchar 255. Now, this is not something I would expect you to know, but I think I did mention it. If it's colored in, it's a little blue diamond here that's colored in, it's not allowed to be null. If it's not colored in and it's a blue diamond, right, then it's allowed to be null. Okay? So varchar 255, varchar 255. Once I've created the person table, I can create table employee. There we go. Employee ID. And guess what? That's my primary key, int not null, auto increment. Person ID. What type is that? An int. And is it allowed to be null or not? Not null. Title, varchar 255, not null. And finally, salary. Is it a double? Not according to that diagram. According to that diagram, it's a float. Float. There we go. Not null. And is that it? How do I bring those two tables together? Foreign key. There we go. Person ID. And then what? References the person table and the person ID in that table. Okay. This is kind of like an interview question. In fact, I worked with a guy that ran a company or ran a consulting company just out of his partner's garage, and he gave me their interview questions, and this is probably where I stole it from. It's just they just have a simple two-table database here. And do you know SQL? Okay, here are 10 questions on this. One of those questions is, how would you have created these tables? And we just did it. Right? So we just passed the interview. Right? So you'll see questions like that. If you're interviewing for a position that requires SQL or something, you could be asked something like that. If you were usually, if it's a coding interview, then you get the standard FizzBuzz kind of crap. But of course, and then maybe you'd be asked, okay, well, hey, that was a great design. They might say, okay, if they wrote that in front of me, they probably know what they're doing. I'll end the interview right here, and then we'll make an offer. Or they might have said, all right, well, now prove to me that you can actually do a join. Prove to me that you can actually do a projection, etc. So we've got a jerk for an interviewer here. Even though we've proved our chops here at these two tables, now he asks us, all right, I want to know what's the total payroll. I want to know how much we're paying all employees. How do we do that? How much is our entire payroll? So select, okay, select what? Count? Is count the correct aggregate? That's the number of records. If I have 10 employees, then it would be 10. I want the sum of all salaries here. So sum of all salary from employee. Do I need to join to the person table at all? No. That's it. That's the sum of the entire payroll. What if I want to find out who is the highest, or what is the name of the highest paid employee? Ooh. So how do I get the highest salary, first of all? Select max salary from employee. Okay. Now, that would just give me one number. I want their name. So select first name, comma, last name, whatever you want to do here, from person. Now, do I need to join over the employee to get that information? Yeah, temporarily I do. Even though I'm not going to use any of the information directly there, I just want the first name and the last name. What I want is, or I could do two nested queries if you really want to. I'm just going to do one here. From person P, join employee E on P dot person ID is equal to E dot person ID. Now, is it okay to use just a regular join here? Yeah, why? If a person does not have a job, then what's their salary? 0, right? Or null. Actually, that's the better answer right there. But when you use null in an aggregate, it ends up being 0. So if you sum 5 plus null, it ends up being 5. 5 plus 0. If you multiply null by something, then it's probably also going to be 0. Right? So join employee E on this, where E dot salary ID, or salary, is equal to this subquery right here. There. Now, will that be guaranteed to give me just one record? The highest paid employee? What if the highest paid employee is paid $1 million a year, but there are two of them, right? The CLO and the CEO both get $1 million a year, right? Then it'll give me both of them, right? So, but who's the highest paid employee? Well, then I guess then it goes down to benefits or something, but we don't have that information here, right? What I want now, what is the sum for each employee? For each employee, how many positions, or for each person, I'll say, how many employee positions do they have? So a one-to-many relationship here. Joe could be the janitor, and he could be the CEO, a CLO, right? And he could also be something else, right? I want to know how many jobs does Joe actually have in this organization? Right? 0, 1, 2, 3. Help me out on this one. I probably want their name. I'll simplify it with just last name, P dot last name. And I want the number of positions. Now what aggregate do I use? Count of everything as num positions from person P. Join employee E. What will this do? All the people that have a job. I still want Joe. Joe's unemployed. Now, Joe Smith has 0 jobs here in this database. So if I want that, then what do I need to do instead of a regular join? A left join. Is that enough? So Joe has 3 jobs over here, CLO, janitor, and database administrator, DBA. How do I collapse that down? Group by what, though? The title, or yeah, the person. And now we've got 2 tables with person ID here, so I'll go ahead and go with E dot person ID. There, that'll do it. What if I want for each person, what is their total pay? What would that look like? Instead of a count, it would be a sum of everything, sum of E dot salary. There we go. Good. Any questions so far? No? All right. Lots of questions that you can ask about one simple 2-table database. Okay. No questions at all? Nope. So then review. It's going to cover everything, basically what we just covered: basic Java, object-oriented programming in the context of Java, SQL and database design, Scantron. Make sure that you bring a number 2 pencil. The Scantron sheets will be provided for you. Don't worry about those. They actually cost 13 cents if you care. That comes with processing too. I'd really like to go and see the machine that does this, because you got to wonder how old is that stuff. But it still works. It will give me back a bunch of statistics. I've used the same test bank for like 5 years now, and add questions every so often, or reframe questions, modify questions, and they've all been validated. So that means that they're all highly correlated with exam scores. There are no gotcha questions. It's 5% of your final grade. You do still have lab tomorrow. Lab tomorrow is covering database table creation. So you still work with that album database, but then you add some tables to model a concert of a music band, and then venues and stuff like that. All right. Okay then. Thursday.